Hello, good morning, everybody. So we will continue with the introduction, where we have completed extract the data from the dataset data equity IDX, where we convert the price index to returns, continuous compounded returns. Then we plot the graph. So we can use a subplot to put two of the graphs together. So you have a subplot. The first argument is 2 row, 1 column, the first graph. Okay, so the bottom one will be 2 row, 1 column, and the second graph. So the first graph is the price index. The second series is the return series. Okay, so you just run it, then you're going to have 2 row, 1 column. Okay, this is the first graph, this is the second graph. So in this way, you can see that the market is actually much more. So in the first period of time, you can see that there's a clear upward trend. Okay, but somehow the fluctuation up and down will be more intense in the second period here. So therefore, the volatility is much more intense as compared to the obvious trend, okay, in this particular region. Okay, guys. So in the next coming part, we're going to simulate because the return series most probably will be symmetrically distributed, and most of the observation will fall within the center of the distribution. Okay, so then of course, if you use a normal distribution, then most of the, if you're talking about standard normal distribution, most of the data are basically okay. So let's say if you have a, so we compare to another distribution, let's say student T. So you can see if this is normal, this is student T with so this is the parameter will be mu and sigma square. So this one will be degree of freedom mu. So student T has the advantage to capture more observation at the tail as compared to normal. Okay, so we just try to simulate this in a diagram. Okay, so let's say we have the second part of the data analysis, which is histogram, or not really histogram, just that is the plots of return series. Okay, not using under normal and student T. Oops. So from this, let's say the returns most probably will be, so let's say this is the center 0. So here maybe obviously the 3%, 2% might be a common return. So this is a return, isn't it? So if you're talking about, let's say, the smallest returns or the negative returns of 7%, and this is positive 7%. Okay, so this is just a assumption for that. So we can have let's say the return we just assume is from negative 7, then with the slot between 0.01 or 0.1, depends on how many observations you want. So you have an interval of, let's say, -7, then the next one is -6.9 until the positive 7. So there are maybe 140 observations there. Okay? So let's say under the normality assumption, So you use the normal PDF to generate the returns with the mean, zero, and variance 1. Okay, so mu and sigma, okay, mu and sigma. So then for student t distribution, let's say we use t, let's say degree of freedom 5. Okay. So you use the t PDF to generate the return with the degree of freedom 5. Nu is 5. Okay, now you can just plot the value. So you can plot two graphs together, return, then first one is the normal. Let's say you can let the MATLAB to decide the color, or the second graph is, so let's say this is the type of line, double dot, blue color. Okay, so this is a two graph. So the title of the graph, normal and students t distribution. Wait, where is this? Return series. Okay, so you can just label the x value will be returns. So this is return series. The y label, the PDF. Probability density function, right? The last one, since we have two graphs, we put a legend. First one is normal. Second one is student. Students T. Oh, this one can. This is student T. Okay. So this way we are able to simulate. So this one, of course, I think we just highlight this to change this to statement now. Change this to statement. Okay, this one. So this is the second part. So now we can just run it. So this one, our student T. Okay. So we can just get rid of this. Okay. You can see this graph from here. You're able to find that the normal is the red color, and then it actually died out very fast. So let's say this is a standard normal distribution. If you have student T with a degree of freedom 5, so we can see it can capture more extreme values as compared to normal distribution. Okay, so in this way, this is a comparison between student T and normal distribution. Okay. So if you want to fit the actual value, let's say, okay, so let's say we just use the data we have collected earlier. I mean, extract from the NYSC data set. Okay. Let's say this is for NYSC return series. Okay, so we just use this. So the first figure we try to now is put it in a histogram. So fit it in a histogram with the return. So the return we're using here is return NYSC. Okay. So let's say we have a bin of 50. So you can fix the number of bin you want. 100 or 50 depends. So the first one is, let's say, the normal distribution. Okay, normal distribution. So the title, let's say, we just put it in as okay, no. So the second graph histogram, sorry, histogram fitting, right? So now we fit the student T distribution, also using 50 bits. So this one you can actually fit it. So the student T location scale, okay, so this is the student T. So it will find out the degree of freedom, okay? So we can actually find the degree of freedom of those. So let the MATLAB to decide for it. So we have a title student T. So, okay. So in this way we can compare the actual value. So just now we have seen the simulated with -7 and +7 returns, okay? So now we look at the actual NYSE. How does it fit? So we just run this and have a look. Okay, so this is the fitting using the student T. Okay, so I think I need a figure to plot another graph here. Okay, so just run it one more time. So you're going to have two graphs here. One is fitting using normal, one is fitting using student T. So obviously you can see that using normal distribution, it actually cannot capture the heavy tail distribution, okay? But for student T, somehow, oh, there's a typo. Student T. So student T, there's a typo. Okay. So obviously, if you use student T, the fitting is by eyeballing. We can see that this is fit much better than the normal fitting. Okay. So in this case, both are symmetrical, but somehow the concentration is small. Okay, as compared to normal. If you use the normal fitting, so for normal it can't actually capture the extreme values, but somehow the student T fit it better. Okay, fit it better. So this is the first preliminary checking of your data set. So you can actually find out the parameter for normal and student T. Okay, normal and student T. So this one is just cancel all this. Okay. So we don't know the mu and the mean. So here we can have estimate the estimate. So now we want to estimate parameter normal student T. Okay. So we just easily use a function called fit normal and fit T. Okay. So fit normal, if you use the maximum likelihood function, the methods to do the estimation. So you have a distribution and which is using normal. Okay. Okay. So it will basically estimate the mu and sigma for us. So the mean for normal. So the first output is the mean. The second output will be so assign a variable to your fit normal. So for the second output is the sigma. Okay, so we can just run this and have a look. So you can see that the mean under the normal assumption is close to 0.0361. The sigma standard deviation is 0.85, close to 1. Okay, close to 1. So how about student T? So this is using the maximum likelihood estimation as well. So the return NYSE. So the distribution we're going to use is student T location scale. T location scale. Okay, sorry, okay, now we can find out the value. So there are three of them. Basically, three of them. Okay, so the degree of freedom is the, okay, never mind. Actually, you can just run this and get the value. So the first observation will be mean is 0.05, close to, so if you compare the normal just now, 0.03, this is 0.05. Standard deviation 0.6, this is 0.5. Degree of freedom is 3.69, close to 5. So financial data normally is going to have the degree of freedom from 3 to 6, from 3 to 6. So the NYSE actually fall within this region. That means it is heavy tail distributed. Or actually, this one is not necessary. Okay, so this will actually tell you when you feed in using a student T. So this distribution have a mean 0.05. Okay, so this is the okay. So normally distributed, the mean is 0.036. Standard deviation is 0.5. For student T, you have mean 0.05 here, close to 0. Standard deviation 0.6. Degree of freedom is 3.69. Okay, 3.69. Okay, so this will be the estimated value for the parameters for student T and normal distribution. So of course, we also like to see how well it fits to a normal distribution using a graph. Okay, so let's say we have, let's say using the QQ plot, quanta plot. So this will check the normality, okay? Of course, you can check the student T as well, right? Student T as well. So this one you have a figure QQ plot. So the function is called QQ plot. Return NYSE. Then, so the value is so we need to minus the mean because, or you can just leave it as this. QQ plot. So this will compare with the series of returns and normal distribution. Okay, so the second graph is, of course, you can put in the actual value for this 0.036 and so on. So for student T, you have, let's say, we make a distribution. Then we have the location, T location. So this value, you have the mean 0.501. So next one is the sigma. Okay, sigma is 0.6033. So therefore, this will compare the returns of NYSE and this student T distribution. So the nu will be, just now is 3.6933. Okay. Okay. So now we can plot the QQ plot. So the series we want to plot is return NYSE, then compare with the PD now. So the first one is return NYSE and the normal distribution. Okay, so it will find out the value for you, but this one we fix because we know this value already. So you can fix in this value. Actually, I think the T location scale might okay, never mind. So just put it in this way. So now we just have a look at it. So this is the quanta plots. If I use the input of sample, which is returns NYSE, and the standard normal distribution, so we found that the center fitting is quite well, but somehow both of the tails is heavy tail. Okay, so this is both heavy tails. So if we use a student T distribution with the specification 0.05, 0.6, and the tail index is 3.699, so we end up to have a much better fitting where not only the center, but of course there are few extreme values which is away from the quanta plots. But by looking at these two graphs, student T distribution might be the better alternative to assume your return of NYSE. Okay, it will be student T distributed compared to normally distributed. Okay guys, so this is the preliminary analysis of the returns of NYSE. Okay, once you get the data. So later we're going to do some modeling based on this. Okay guys, so see you guys in the next session. Bye bye.